Hi everyone, welcome back to LikedList 2.0. LikedList 2.0 in the sense, in the previous video we just did some basic things about the linked list, just insertion and deletion, but in this video we are going to do a lot more, like sorting, searching, traversing, and identifying a lot more things. So let's get started without wasting your time. This is all what I had done in the previous lecture, so the link will be in the description. You can go and check all the details about how linked list works and how we are going to use that. And today in this lecture I am going to use 3 classes for Java creating a linked list, because for the first class I am putting it name as link node. In the sense, node means it will create a memory for that. In that memory I am going to store some data, and those nodes will be connected by some link class. And in the main class I am going to create object for link class. There I am going to use methods and attributes for that linked list. So this is how my program works simply. I think you all got it right. So let's get started. See, this is the simple code for the node. See, in the node class I am just having an attribute data, and it's of integer type, and after that I am having another attribute that name is link, and that link is of node type. I set it as a node type because I want that link to refer to another object, so that's why I put it as node type. You got it right? In that node class I am having a constructor, with that constructor accepting an integer type parameter, and that will be assigning to the data, and the link will be setting to null. Here why I am setting the link will be null as because I am just inserting all the nodes at the end. I am not inserting at the middle, I am not inserting at the beginning. I am just inserting at the end. This is how my logic works. If your logic works differently, you can write your own logic. You got it right? After that I am having another class, that is link class linked. In this class I am going to define methods and attributes for the linked list. See, here I am having 2 attributes, and those attribute names are head node and tail node. Initially I am setting them as null because initially there is no nodes in the list. If the user wants, then only we want to create those nodes. This is my logic. You got it. After that I am having an insertion method. In that insert method we are just taking a parameter of integer type, and in the first if condition I am going to check whether there is elements or not in the list. If there are no elements in the linked list, I am just going to create a node, and I am going to point head node and tail node to that object. You got it right? This is a simple logic. After that, in the else statement I am creating another object. I am making it as a tail node. This is another logic. So I am having 2 conditions here, whether there are elements or not. This is the only condition that I am checking. If there are no elements, I am just creating an object, and I am referring both head node and tail node to that object only. If there are some elements in the list, I am just creating an object. I am just referring tail node to that object. You got it right? After that I am having a delete method. In the delete method we are just taking a parameter of integer. Like the same in the previous, we are just checking whether there are elements or not. If there are no elements in the list, I am just returning. If there is an element, if there are elements, what I need to check? I need to check whether the head node itself is having the data or not. If the head node data double equals to a, what I need to do? I need to delete the whole head node. What does it mean deleting? We are just removing it from the linked list. So I am just making it as head node equals to head node.link. So the next node will become the head node. But here I am not freeing any memory for the previous head node, because here we are having garbage collector in Java. If you don't put any reference to an object, that will be collected by the garbage collector and the memory will be deleted. You don't need to worry about the memory here. If that condition also fails, what does it mean? The node that we want to delete is somewhere in the list, so we need to traverse the whole list. So I'm starting from the head node and I'm traversing the whole list. If that becomes null, which means there is nothing element like that we want to search. So in that case we are just returning with the printing not found. Until we need to traverse the whole list. So I am making it as p equals to p.link. If I found that, what I need to do? I just need to delete that. Delete in the sense means we are just removing it from the linked list. So p.link is equals to p.link.link. You got it right? This is a simple logic. This is how my delete method works. After that I am having a search method. In the search method I am just taking an integer parameter. I am just traversing the whole list. If there is any element like a, I would just print found in the list. If there is nothing like that, I would print not found. This is my logic. After that I am having another method that is length. It's taking nothing parameters, but it's returning an integer. I am just taking an integer, local integer I equals to 0, and I want to traverse the whole list. I want to increment it again and again until it becomes null. So the length of the list will be in I. So I am just returning it in the last statement. So got it right? How to calculate the length of the linked list. After that I am having toArray method. ToArray method will return an integer array. So it will traverse the whole list and add those elements to an array, and it will return that array. This is a simple box, but here I am taking a parameter integer n. Here n in the sense means the length of the linked list. They should definitely give that because we are just taking it as an array. So we need to create memory for array. To create memory we should know the length of that, right? So that's why we should definitely pass the length of that linked list as a parameter to array method. After that I'm having a sort method. That sort method is also taking parameter as integer length, and that is returning a linked list. See, it will create an array. After that it will add all the elements from the linked list to that array. After that what it will do, it will sort that array with any kind of sorting algorithms, whatever kind you want, like bubble sort, insertion sort, merge sort, quick sort, any kind. After that I'm going to insert these array elements into the list again. So this is the simple logic, works in the 3 steps. You got it right? After that I'm having another method, that's a simple method traverse. Traverse method will traverse the whole list and print them one by one. This is a simple logic. You got it right? In the main class I'm giving the user experience. So I'm giving the user options: insertion, delete, search, toArray, sort, traverse. After that I'm just asking the user to enter your option, what you want to do. If you want to insert, I'm taking input from the user, I'm going to insert it to the list. If you want to delete, I'm taking input from the user and I want to delete that. If you want to search something, I would take input from the user and would search that. If you want that to convert to an array, I will do that and it will print that array. If you want that linked list to be sorted, I would sort that. After that I would print successfully sorted. If you want to traverse the list, he would traverse the list with the traverse method. If you enter anything other than this, what it will do? He will ask for enter valid input only. I want only 1, 2, 3, 4, 5, 6. I haven't defined any other method, so I'm just putting default as enter valid options only. I think you got it right. This is a simple program. Let me run this, compile this first. I think it won't give any errors. Yes, it's asking for the user to input. I'm just inserting the element successfully inserted. After that I'm inserting some other terms. Whatever you want, just insert it. See, I'm just inserting any kind of data I want. See, successfully inserted, successfully inserted, successfully inserted. If I traverse the list, see it's showing 23, 56, 567, 456, 0 and 1. Here, this is how I am taking inputs from the user to insert. If I want to delete something, let me check whether I can delete this or not. Sorry, let me delete something like 23, 56. Let me delete 56. If I do traverse the list, it will be showing all the things other than 56. You got it right? This is how delete method works. If you want to search something, if I want to search whether 0 is in the list or not, it is showing yes, found in the list. If I try to search 2, it's not in the list, right? So it's not found. This is a simple logic what we have written previously. If I want to convert it to an array, yes, it's loaded to an array and array elements are printed with the indexes. If I want to sort that list, I would just sort it. Yes, successfully sorted. After sorting, I would traverse the list. See, 0, 1, 23, 23, 4, 56, 5, 67. So this is how it will sort all the things. If I enter anything options like that, if I say 9, there is no option like 9, right? So it will print enter valid options only. So this is how my program works. This is a simple program, right? This is all the links for the files, code files and ODT files will be in the description. Please do check that. If you haven't subscribed to my channel, please do subscribe to Dumb Minds. Thanks for watching.